phosphorylation. Phosphorylation, you already know, means addition of a phosphate group to some substance, or you can say it is synthesis of ATP. And energy needed for synthesis of ATP that comes from oxidation reduction reactions. That is why it is called oxidative phosphorylation. Okay? The oxidative का मतलब ये है कि oxidation of NADH2 and FADH, or energy needed for synthesis of ATP comes from oxidation reduction reactions. That is why it is called oxidative phosphorylation. Okay, if we look at this structure of mitochondria and we cut a part of it from here and we redraw it as an enlarged view, so we will see this is an outer membrane. This is an outer membrane. Here we have an inner membrane. And there is a fluid-filled space inside. Which is known as intermembrane space. And we can draw crystal or a stark particle here. This is a stark particle. I'm sure you know this inside fluid in the mitochondria is called mitochondrial matrix. So this is matrix here. What would be the fluid present on outside of this outer membrane? Do you think it will be cytoplasm? Okay. So you know there are chemical reactions taking place in the mitochondrial matrix. It is link reaction, Krebs cycle taking place here in the mitochondrial matrix. And as a consequence of that, there is NADH2 and FADH being made. This NADH2 need to be reoxidized so that glycolysis, link reaction, or Krebs cycle that continues. So it has to be reoxidized to NAD. When it is reoxidized to NAD, the hydrogen is removed out of it. Okay, so this is hydrogen removed out of it. So it is passed to a first hydrogen carrier here. This is hydrogen carrier. Hydrogen carrier. So when it receives hydrogen, it becomes reduced to itself. And when it gives out hydrogen, it becomes oxidized or reoxidized. There is a proton pump associated with this hydrogen carrier. Okay, so this is H pump, and there are electron carriers present here too. This is an electron carrier. So this is how a series of electron carriers is present on inner surface of inner mitochondrial membrane. इसको हम कहते हैं ETC, यानी electron transport chain. When this NaDH2 is reoxidized to NAD, hydrogen is removed out of it. This hydrogen splits into two parts: hydrogen ions plus electrons. Hydrogen ions are pumped out of the matrix into the intermembrane space through these hydrogen ion pumps by an active transport or by use of energy. Okay, whereas electrons are passed to this electron carrier, so this reduces this electron carrier. I'm sure you have understood what happened to the hydrogen that is removed from NaDH2 here. It splits into hydrogen ions and electrons. What happened to hydrogen ions? Hydrogen ions are pumped into the intermembrane space by active transport, whereas electrons are passed to an electron carrier. Got that? Now these hydrogen ions have high concentration in intermembrane space than in mitochondrial matrix. So what happens? They diffuse down the electrical gradient through stark particles.
सर ये इलेक्ट्रॉन पंप का नहीं समझ आया मुझे.
जैसे कैरियर प्रोटीन्स होती हैं सेल सरफेस मेम्ब्रेन के अंदर, they bring about the movement of ions against the concentration gradient, तो उनको हम पंप कहते हैं.
ठीक है.
Okay. So this is hydrogen ion pump. आपने ये हाइड्रोजन आयन पंप जो है वो जब आपने एक्टिव लोडिंग ऑफ सुक्रोज इन द सीव ट्यूब्स किया था तब भी पढ़ा था. ठीक है. अच्छा जी. So these hydrogen ions diffuse down the electrical gradient through stark particles. While moving down the electrical gradient, they activate an enzyme here, which is known as ATP synthase or ATP synthetase. This diffusion of hydrogen ions through stark particles activates ATP synthase, and this causes an ADP to react with an organic phosphate to make an ATP. This synthesis of ATP is called oxidative phosphorylation. इससे हम कहेंगे oxidative phosphorylation, or may be also known as chemiosmotic synthesis of ATP. Okay, so ATP is synthesized here. What happened to this hydrogen ion? At the same time, oxygen diffuses from outside and is used as final electron acceptor. An enzyme present here with this electron carrier known as cytochrome oxidase causes electron to be passed to this oxygen here. तो यहाँ से जो electrons थे electron carrier से they are passed to this oxygen. तो इस तरह से ये electron यहाँ आ जाएंगे और साथ ही ये जो oxygen थी this also diffuses here. So oxygen plus electrons plus this hydrogen ions, they react together to make water here. This is known as metabolic water. Correct? So hydrogen is finally disposed of in the form of a non-reactive substance, metabolic water here. So this is oxidative phosphorylation. Okay.
सर क्या आप री एक्सप्लेन कर सकते हैं कि जब ऑक्सीजन एंटर होता है तो वहां से एक्सप्लेन कर दे सर फिर से.
हाँ, ऑक्सीजन जब डिफ्यूज होगी into the mitochondria, so on the inner surface of inner mitochondrial membrane, there is an electron carrier which has an enzyme cytochrome oxidase present with it. It causes electron, or it passes electron to oxygen, and oxygen acts as final electron acceptor here. So this electron, oxygen, and hydrogen ions finally they react together to make water, which is called metabolic water.
Okay sir, thank you.
Right. Okay. So now let's see the net yield of energy during aerobic respiration. When one NADH2 is reoxidized to NAD, 3 ATP molecules are made. Some energy is used for active transport of hydrogen ions into the intermembrane space. So only 2.5 ATP are produced. When one FADH is reoxidized to FAD, so 2 ATP are made. Some energy is used for active transport. So net 1.5 ATP are produced from 1 FAD. We discussed in the net yield of Krebs cycle, link reaction and glycolysis. Like if it is glycolysis, this is link reaction. This is Krebs cycle. And this is oxidative phosphorylation. So let's see how many ATP are made in each process. Glycolysis में there are 2 ATP made. Link reaction में there is 0 ATP made, and Krebs cycle में there are 2 ATP made. और oxidative phosphorylation में कितने ATP बनते हैं वो भी हम कैलकुलेट करते हैं. Now let's see how many NADH2 are made. There are 2 NADH2 made in glycolysis, 2 NADH made in link reaction, and 6 in Krebs cycle. So how many total NADH2 are made? 10. और अभी हमने डिस्कस किया if there is one NADH2, so 2.5 ATP is formed. If there are 10 ATP, so how many? Sorry, if there are 10 NADH2, so how many ATP will be made? 25. तो ऑक्सीडेटिव फॉस्फोरिलेशन में कितने ATP बनेंगे? 25. Okay. Now let's see FAD. 0 FAD formed in glycolysis, 0 FAD in link reaction, 2 in Krebs cycle. And we already know If one FADH is reoxidized, 1.5 ATP is made. As there are two FADH, so there will be 3 ATP made. So during oxidative phosphorylation, there are 28 ATP molecules made. ट्वेंटी एट ये और दो ये और दो ये, तो कितनी हो गई टोटल एटीपी मेड? Total ATP made during aerobic respiration will be instead it is, क्योंकि जो यूज थी वो हमने निकाल दी है, so this is net ATP produced or ATP made during aerobic respiration is 32 ATP. Okay. And we can also write about carbon dioxide. Zero, 2, and 4. Okay. So total there are 6 carbon dioxide made. There are 2 FAD and there are 10 NADH. और total ATP जो है वो कितनी हमारे पास हो जाएगी? That is 32 ATP. So this is total. Is it okay?
Yes, sir.
So now